Hi, this is Nick in 3WG, and in this video we're going to be looking at a new product / project I've been working on. This project has been in the works for quite a while, probably since August of last year or so, August 2013. So this you've probably seen before. This is the Pig knob, and it's basically just a rotary encoder in there. It's an optical encoder, and it's got several buttons on it. 8 buttons here to put macros in there. So it's just a remote tuning knob. When I released this, I had several emails come in saying, yeah, that's great and all, but I would really like a keypad to do direct frequency entry type stuff. So I batted around the idea for quite a long time, and what I started with was just a microcontroller similar to what's in here. This has a microchip PIC 18 in it. And so I was going to make something similar with something like this, just tactile switches. These particular ones, you can take the caps off and label them however you want. And that became quite a bit of a pain because you got to make, switch matrices, and it didn't allow for much flexibility. So then I moved on to the next idea, which was using something like this, which is a resistive touchscreen. It's got the plastic still on it, but what I was going to do was build a keypad on here, and you could tap, and I actually got this working. This is also controlled by a microchip PIC. This is not my design. This is a development kit from the company that makes this controller for this guy right here. And my problem with this was there was no tactile feedback. You had no idea what button you were pushing, so it was kind of hard to use. So another problem I ran into was the number of pins available on this were mostly taken by this, I forget what this device does. It has something to do with video memory. So I ran into some pin problems with this guy. So this was also dumped, similar to the switch matrix thing. And then I had an idea one day in the shower. What would be really perfect for this is something like this. This is an off-the-shelf USB keypad. Now you plug it into your computer and you can type numbers, and it works great. So then I was faced with the problem of interfacing this to a microcontroller. So that's what I started working on, and I went through several iterations of that as well. But I have it working now. So that's what we're going to take a look at today. Here's another example of one. This one is actually wireless. You plug this into your computer, and then this would sit next to your mouse or whatever. So my thought was make a little box that sits hidden away. This would sit next to your mouse. This would plug into that little box that's hidden behind the desk, and also plugged into that little box is the computer as well as the radio. So with the knob, what I have coming off of here, this is an RJ11, and 4 of these conductors are used for serial connections. One goes to the computer and one goes to the radio. So it actually acts as a proxy. So what I wanted to do was the same thing with this project. This is actually not the box I'm talking about. This is straight off the shelf from Office Depot. I think it was 12 bucks. So what I wanted was a box that did something similar. So we had a serial on 2 sides, one for the computer, one for the radio. So here's the prototype here, and the name I'm batting around is PigPad, keypad, get it? If you come up with a better name, let me know, and there might be one of these in it for you. So what we have here, we have the USB connector. That's where this goes. We have an LED here that tells you a couple things. Either it's on and working or you're configuring it. Then we have a pot right here. And that pot, what it does is it raises and lowers the volume to the speaker, which we'll get into what that speaker does in a minute. Coming off the back here, we have 2 connections. This is to the radio, and I know I'm going to get a lot of, or at least a few email comments about why I went with RS-232 DE9 serial, but trust me, there's a reason. And then on this side, we have a micro USB connector. And that actually goes to the computer, and it presents itself as a serial port. So basically, any characters or bytes coming into this serial port are looked at and then sent to the radio and vice versa. So it'll, in its default mode, it'll just proxy back and forth. This right here is an ARM Cortex M4 processor, and this is actually going to come as a module for quick replacement if necessary. And this will actually be a single row of pins right here. This just happened to be all I had available. Alright, so what else do we have on this board? We have a Max 3232. This is doing the level shift from the UART here to RS-232. This is a EEPROM for storage of configuration of this guy. And this right here is a USB host controller, which was a lot of fun to hand solder. And then oscillator and various passive components to make all this stuff work. So what's the speaker for? It's for feedback. So inside, so this, like I said, is just off the shelf. And the way it works is there's two modes. There's direct frequency entry and macro mode. Currently there's up to a maximum of 9 banks of 10 macros at 100 characters each. So it's 90 macros of 100 characters each. And you switch between banks by hitting numlock, and the speaker will tell you what bank you're in. Currently it's CW. I'm investigating the possibility of just making that spoken voice, and we'll see where that goes. Alright, so straight out of the box, there's 2 banks, and you just hit numlock, it'll go to bank 1 or bank 2. Then as you press numbers, it sends the macro that's configured for that particular bank / key number. So if you're in bank 1, button 1, then that's macro 11. Bank 1, button 2 is macro 12, on down the line. If you press enter, that'll go into and out of direct frequency entry mode, DFE mode. And when you go into and out of those modes, it'll either say M or D in CW off of this guy. Also with the CW, you can change the words per minute as well as the frequency of the tone that's generated there. Let's see, plus, minus, multiply, and divide. What this does is send up, down, up fast, down fast. So this, with an Elecraft radio, for example, this would go up, what is it, 10 hertz. 10 hertz, and then this will go up 1 kilohertz, or down. I don't have anything in there for backspace yet. But let's plug it in and see how it works. Let's see here, when we plug in the... Also, there's a full set of configuration on this guy, which we'll look at. So we're going to plug in the keypad here. I will plug in this micro USB cable here, which I'm going to plug into my computer, which is off screen. And we'll plug in the radio. In this case, it's a KX3, but I'm looking to be radio agnostic. So let me plug this guy into my computer. So the light come on there. Alright, so it's powered up. Now let me hit one of these buttons. So I just hit the 1, and you saw that it went to 10 meters there and USB. So I'll hit the 2 now. And this is all just because of what I have configured in the device itself. And when it booted up, it read its configuration from EEPROM. And now it's just, as key presses happen here, it's doing what it's told. I just hit 3. So let me switch banks so you can see what it does. So now I'm in bank 2. It just did a Morse code character 2. Now I'm back in 1. And you can configure a maximum of 9 banks. So if you log into the config program and do set banks 9, then this would actually count up 1 through 9. And then you can configure the buttons to do what you want. For direct frequency entry, so it just sent D. So now I'm in direct frequency entry mode. So now if I type a frequency in here like 7040, enter. It went back into macro mode, so that's why you heard the M. And it went to 7040 back there. So let's go to 1, 2, 3, 4. There we are. Also the triple zeros work as well. So if I do 14000. We're at 14 megahertz. So that's that. Let's look at configuration of this. I'm going to pause the video so I can orient the laptop so you can see it. Okay, we're back here. I have the computer terminal brought up here. So what I'm going to do is open up Minicom, which is just a terminal emulator. Alright, so if I type in here, like I just did FA semicolon, so that sent the command to the radio to query VFO-A frequency, and that went through the pad here, pad question mark, if that's what we're going to call it. So this could be a logging program that's talking through the pad. Alright, now if I hit $3 I'll get into config mode. If I do an H for help, there's a lot of stuff I can do here. It looks like I can't scroll up. Alright, so we have set baud, set banks, set key repeat. So this is how quickly it will repeat a key as you hold it down. Words per minute, frequency for CW. DFE CW, so if I turn this on, so if I do set DFE CW1, it gives you a little note here saying be careful with this because it blocks. So if I go into DFE mode, as I hit each character, it'll give me CW feedback. And then it sends it. But you can't type quickly because you have to wait for the CW to finish. So let's turn that back off. The banks I was talking about, set banks, let's do 6. If I do P for print, it'll give me the current config. So I can see that CW frequency is 600, words per minute is 30, key repeat is 200 milliseconds, Elecraft, radio, we specify the radio type here for the direct frequency entry, so it knows the correct way to format the command. So here's the banks. I just set that to 6. So now as I cycle through banks, I ran out of space on the card right when I was hitting that numlock button, so I just pulled some files off, and here we go again. I usually try to keep the videos under 10 minutes, but this one's not that quick. Alright, so we're at bank 6 right there. So there's bank 1, 2, 3, and back to 1. You can see here these are the macros we have configured. So bank 1, key 1 puts us on 10 meters. Bank 1, key 4 would send this Morse code string with the KY command from Elecraft. So if I go to 30 meters CW and hit 4, see the light blinking down there, and the text being decoded right there. Or if I go to bank 2 and hit 1, once that's done, looks like I might have tapped it twice. There's 29 megahertz, 15, 11 megahertz. So that's that. We have macros and direct frequency entry in standard off-the-shelf USB keypad, all being managed by this little ARM processor here. Oh, and that the LED is blinking because we're in config mode right now. The reason I did that is because if you're in config mode and you have a logging application talking to it, it won't actually send it to the radio. It's processing it as a command. So we have to leave config mode, and then we can send our commands to the radio and get information back. So let me know what you think. I should hopefully have these available for Dayton, and it's most likely going to be in this case. Like I said, the name is still up in the air, but right now I've been calling it PigPad. Also, this case is just dremeled to make it fit. So, That's what it'll look like. Let me know what you think. Thanks.